Oh, hello there. I'm just reenacting the famous kite experiment by Sir Benjamin Franklin, in which he discovered that lightning is made of electricity. Good morning, grade 7 learners. Welcome to another episode of Valenzuela Live. I am Sir Fernand Cebu from Polo National High School, and I will be your virtual science teacher for today. Join me as we explore the wonders of electricity. For today's lesson, you will learn to describe the different types of charging processes. Specifically, you will learn to define atom and identify its particles, define electric charge, and explain how atoms becomes electrically charged. Demonstrate charging by friction, show through diagrams charging by induction, and explain charging by conduction. Here are a few reminders before we start with our discussion. First, use the chat box in asking and answering questions. Second, is to use appropriate words when chatting in the comment section. Let's have a recap about heat or the topic that you have discussed last time before we proceed with our discussion. Click the heart button if the statement is correct and like button if the statement is wrong. You have 5 seconds to answer each question. Question number 1. Heat can be transferred in 3 ways: conduction, convection, and radiation. Is it hot or light? Okay, the correct answer is hot. Question number 2. Conduction and convection need a medium or matter for the heat to transfer from one place to another. Is it hot or light? The correct answer is hot. Number 3. When heat moves through an object by conduction, it causes the atoms in the object to move slower. Is it hot or light? Click your answer. The correct answer is light. Before we start with our discussion, I want you to watch what will happen to the tin can as I move the PVC pipe near it. Okay, watch. What did you observe? Correct. Nothing happened. Now, I will rub the PVC pipe with a silk cloth and move it near the tin can. I will just rub it. And then observe what will happen to the tin can. So the tin can moves. Let's try to rub it again. Okay. So what did you observe? Why do you think this happens? Before we start with our discussion, I want you to watch what will happen to the tin can as I move the PVC pipe near it. Okay, watch. What did you observe? Correct. Nothing happened. Now, I will rub the PVC pipe with a silk cloth and move it near the tin can. I will just rub it. And then observe what will happen to the tin can. So the tin can moves. Let's try to rub it again. Hey, so what did you observe? Why do you think this happens? Would you believe that the attraction comes from the particles that we cannot see using our eyes? And those are atoms. All matters are made up of atom. Atom is the smallest unit of matter, and it is the building blocks of matter. It is composed of three subatomic particles: the proton, which is positively charged, the electron, which is negatively charged, and the neutron, which is neutrally charged or no charge. Atom is also divided into two regions: the inner region or the nucleus and the outer region. The inner region or the nucleus is composed of proton and neutron. Since proton is positively charged and neutron carries a neutral charge, then the charge of the nucleus is positive. The outer region of an atom holds the electron, a negatively charged particle that revolves around the nucleus. Materials that are made up of atoms are neutral or has no charge. This is because the number of protons and electrons are the same. Therefore, the atom is said to be neutral. Let us prove this statement through an example. A material is made of helium. Helium has an atomic number of 2 and atomic mass of 4. Therefore, it has 2 protons and 2 electrons, as well as 2 neutrons. We can determine the charge of an atom by adding the number of protons and electrons with respect to their charges. For our example, helium has 2 protons that are positively charged, and so we will put positive sign before the number. Aside from the 2 protons, helium also has 2 electrons. Negative sign is to be written to denote the charge of the electron. Helium also has 2 neutrons, which is neither positive nor negative. The nucleus of a helium atom has 4 particles, and those are 2 protons and 2 neutrons. The charge of the nucleus is positive because of the charge of the proton. To determine the charge of the atom, we should add the number of proton and electron with respect to their charges. So positive 2 plus negative 2 would result into 0. Therefore, materials with the same number of proton and electrons are said to be neutral. But how come that some materials are positive or negative in charge? According to the law of conservation of charges, charges cannot be created nor destroyed, but it can be transferred from one material to the other. Here's an example. When we rub fluorine, a material made of fluorine, and a material made of carbon, electrons will transfer from carbon going to fluorine. In this case, the electron of carbon will transfer to fluorine. Before the charging process or before the electron transfer, fluorine has 9 protons and 9 electrons, making its charge 0 or neutral. Carbon has 6 protons and 6 electrons, making its charge 0 or neutral also. After an electron is transferred, fluorine now has 10 electrons and 9 protons. Mathematically, positive 9 plus negative 10 would result into negative 1. Therefore, the charge of fluorine will be negative 1. For carbon, it will still have 6 protons, but after transferring 1 electron, it will only now has 5 electrons. So, positive 6 plus negative 5 would result into positive 1. Amazing, isn't it? This is how electrons determine the charge of a material. When it receives an electron, it will become negatively charged, and material becomes positively charged when it loses an electron. Do you wonder which material will give or accept electrons? It depends on its position on the triboelectric series. Triboelectric series is an arrangement of material or substances according to their ability to gain or lose electrons. The farther the material are from each other in the series, the greater the charge transfer. Here's an example. A glass and a PVC pipe rub against each other. The glass, which is located in the upper position, tends to give electron and becomes more positive, while PVC, being located at the bottom, tends to accept electron. Therefore, it makes the glass positive and makes the PVC negative. Let's see whether you understand our lesson. You are going to determine the charge of the material based on which one gives off or receives an electron. For practice, what would be the charge of a silk and a styrofoam when rubbed together? If you answered that the silk would become positive and the styrofoam would become negative, then you are correct. Since silk is located in the higher position in the triboelectric series, it has a greater tendency to give off electrons and become positive, making the styrofoam negative. Now, it's your turn. Type the charge of the paper and the Teflon after rubbing. Type your answer in the comment section. By looking at the triboelectric series, the paper will become positive in charge, while the Teflon will become negative in charge. The transferring of electrons determines the charge of the material. The next question is, how do materials transfer electrons? To better understand charging processes, we need to understand the law governing electric charges. Based on electrostatic law, it states that like charges repel and unlike charges attract. When two positive charges are brought near each other, they repel, the same as when two negative charges are brought together, they also repel each other. But when we put unlike charges, a positive and a negative charge, they will attract. Let us now go back to the question, how do materials transfer electrons? The transferring of electrons in a material can be done in 3 charging processes. That can be charging by friction, charging by conduction, or charging by induction. Charging by friction happens when two materials are rubbed with each other. Electrons transfer from one material to another through direct contact. An example is rubbing of rug and a PVC pipe. The PVC pipe and the rug are both neutral in charge before they are being rubbed. But after rubbing, the electrons transfer from the rug to the PVC pipe. Since the rug gives off electrons, it becomes positive, and the PVC pipe, which gains electrons, becomes negative. We should take note that during charging by friction, there is physical contact between the two materials, and such materials are both neutral prior to rubbing. The second type of charging process is charging by conduction. This happens when a charged material is in contact with a neutral material. In this example, a negatively charged rod touches a neutral sphere, or we can call it as metal sphere to be exact. During the contact, electrons are transferred from the rod to the metal sphere, making the metal sphere negative in charge. Take note that during this process, one material must be charged and the other one is neutral. Electrons transfer from the negatively charged material through direct contact. The third type of charging process is charging by induction. This happens when a charged material is brought near a neutral material. The charge inside the neutral material separates into positive and negatively charged. As shown in this example, negatively charged rod is brought near a neutral metal sphere. Take note that it doesn't touch the metal sphere. When the rod is near the metal sphere, the electrons of the sphere moves away from the negatively charged rod. This happens because it follows the electrostatic law. Unlike charges, repel. Therefore, electrons moves away from the negatively charged rod. Take note that during this process, there is no contact between the two materials, a charged and a neutral one. There is no electron transfer that happens. Instead, there is a rearrangement of charges inside the neutral object. To give you another example, I have here a PVC pipe and a silk. I will rub the PVC pipe with a silk cloth. What type of charging process happens between the PVC pipe and the silk cloth? Correct. This is charging by friction. What is the charge of the PVC pipe? Correct. Negative. Since PVC material is located at the bottom of the triboelectric series. Now, let's have a sphere with 8 protons and 8 electrons. The charge of the sphere is neutral or no charge. I will bring the PVC pipe near the sphere. Observe what will happen to the charges of the sphere. Okay, so the negatively charged particles moves away from the PVC pipe. The question is, what type of charging process happens? Correct. It is charging by induction. Now, observe what will happen when the PVC pipe touches the sphere. Okay, so electrons transfer from the negatively charged PVC pipe to the neutrally charged sphere, leaving the sphere negative in charge. What type of charging process happens here? Correct. It is charging by conduction. Now, let us wrap up to know whether you understand our lesson or not. Let us answer these questions. Type true if the statement is correct, and if the statement is wrong, type false. So, let's start. Question number 1. An atom is composed of subatomic particles, proton, electron, and neutron. The answer is true. Question number 2. Electrons are positively charged particles that are found inside the nucleus. This is false. Electrons are negatively charged and can be found outside the nucleus. Question number 3. The nucleus of an atom is positively charged and composed of protons and neutrons. The correct answer is true. Since proton is positive and neutron has no charge, hence the nucleus possesses a positive charge. Question number 4. Materials can gain electric charges when electrons transfer from one material to the other. The answer is true. Question number 5. Charging by friction happens when two materials rub each other. Okay, this is true. Charging by friction happens when two objects have direct contact. Question number 6. When a charged material is brought near a neutral or uncharged material, and electrons transfer from one material to the other, this is called charging by induction. Okay, the correct answer is false. Question number 7. When a neutral material rearranges its electrons so that it will be attracted or repelled by a charged material, it is called charging by conduction. The correct answer is false. Charging by conduction transfers electron to the neutral material. Question number 8. Positive charges repels negative charges. Correct answer is false. Question number 9. Unlike charges repel. The answer is false. Unlike charges attracts. Like charges repel. And lastly, question number 10. The law of conservation of charges states that charges cannot be created nor destroyed, but can be transferred from one material to another. Okay, the correct answer is true. Now, I think you all know the different types of charging processes. This time, I will be answering questions related to our topic today. Question number 1. What is the difference between charging by induction and charging by conduction if both of them needs a neutral and a charged material? Okay, this is a good question. The difference between charging by conduction and charging by induction is charging by conduction needs a direct contact, and there is a transfer of electron that happens from a charged material through going to a neutral material. For charging by induction, there is no contact between the two materials, and there is no electron transfer that happens. What only happens is there is a rearrangement of charges inside the neutral material. Question number 2. Why is it that electrons are being transferred, not the protons? Okay, this is a good question because we are speaking of electron transfer. Protons cannot be transferred because it is found inside the nucleus, and there is a strong nuclear force that holds the nucleus inside the nucleus that holds the protons and neutrons together. So the one that can be found outside the nucleus and can easily be transferred are the electrons. Okay, so that's all for today. Good day everyone, and keep safe.